Okay, now we are finishing up the confidence interval PowerPoint. The width of the confidence interval is always determined by two things. The confidence level, which is 90%, 95%, and so on. And that's what gives us our Z that we're going to use. So the bigger the confidence level, the bigger the Z, the wider the level. The sample size, which is N, and again, that's always on the denominator of the standard error equation, so that's going to have an inverse effect. So as the level of confidence increases, the 90, 95, 99 makes a bigger Z, wider interval. As the sample size increases, because it's on the bottom of that fraction, it's going to make the confidence interval smaller. This is 4 setups of the same population to show you the difference between 95, 99, 100, and 50 sample sizes. The answers are in your notes packet. All right, now we are talking about what happens to the confidence interval as different things happen. As sample size, the confidence interval does what? Well, the confidence interval is always a point estimate plus or minus this margin of error, and the margin of error is standard error times C. So sample size, where does sample size come in? Sample size comes into standard error. Well, for proportions, we're talking about this thing, which makes sample size on the bottom of this fraction, bigger denominator, smaller fraction. So standard error decreases. So as sample size increases, the confidence interval will decrease. What about as confidence level increases? Well, confidence level is what determines the Z. So as Z goes up, we're back to looking at this formula where margin of error equals standard error times Z. Well, if Z goes up and we want the same product, well, the standard error would have to go down, which means the sample size would have to increase. They have a reciprocal relationship. As confidence level increases, again, Z goes up. Well, Z is in the margin of error formula, and so the margin of error will increase as well. All right, we're going to look at a problem here that says the retention rate for this sample was 71.9%, and we want to estimate the national retention rate. According to CLT, our sample is big enough, we assume it's random and independent, so we need to do a couple things here. We're always going to have a Z, which is 1.96 based on this number, and we need a standard error, which in this case is the square root of 719 over 0.281 over sample size, and that equals 0.0200. Now our point estimate is our p hat, which is 0.719. So our confidence interval is going to be 0.719 plus or minus 1.96, 0.0200, which gives us the interval of 0.6798 to 0.7582. And we will say we are 95% confident that the true retention rate is between 0.6718 and 0.7582. And that is how you do a basic confidence interval calculation with proportions. If we went to a 98% confidence interval instead of a 95, which would be wider? Well, the 98 would be wider. Again, we talked about that on the previous slide. And if the sample size would increase, the confidence interval would decrease. So that's the two answers to that. The next two are problems that are on the slideshow, but the answers are worked out in your notes. If you have specific questions about those, please let